Good afternoon. Welcome to Trailhead DX, Mastering the Lightning Framework. My name is Jean-François Paradis. I'm a developer on the Salesforce Lightning Framework. And I'm going to be with you for the next 2 hours. We're going to take a deep dive inside of the framework. And we're going to want to cover a few things with you today. So at the end of this talk, what we want to make sure that you cover and you understand is what is Lightning and how it compares with other single-page web application frameworks. We want also to talk about component-based architecture and how it relates to regular traditional object-oriented programming. We also want to cover the 4 languages that are inside Lightning, so XML, CSS, JavaScript, and Apex, and how you can use them to build large single-page web applications. Now, Lightning is not the only single-page application framework out there. There are others. Here are some examples. And Lightning follows a lot of the trends that are composed in modern single-page application framework. For example, we have things like rendering that is similar to React. We have a binding similar to Ember. And we do styling like Sass and Bootstrap, all under the framework. But we also look ahead. We're trying to follow what's happening with web components. We're very interested by this native future support of web components in the browser. And we're also a member of TC39, the committee that drives JavaScript into the next standards. And we want to be part of it and contribute to this new future. But there are things we do differently with the framework. For example, we have things like access rights, which allow components to have privacy. We also have a secure DOM and a secure execution context. So when you have 2 widgets on the page, they cannot see each other and they cannot interface with each other. So this is great for security, but also for stability. We aim also to have a stable API where we make sure that your components that you write today will work tomorrow. And we aim to have a complete platform, so we integrate everything and we do the work for you. And obviously, another focus is on App Exchange, on this ecosystem. So we make sure that we can interoperate with the Visualforce, so you can put those Lightning components inside of your Visualforce page. And if you want to do the work and convert to Lightning, then you can reuse a lot of your server-side assets and inside of Lightning. For example, your Apex controller should be compatible without any change. Now, Lightning, under the hood, has another framework. It's called Aura. And Aura is an open source framework. So it's available at this address. Think of Aura like in Lightning, like WebKit in Safari and Chrome. We do this for transparency. We do this because it's a great learning tool and we're open to contribution. And it's a place also to see what's coming. What are the new features that might come into the platform later. Now, Lightning is a complex framework. We could draw multiple diagrams to try to explain its structure. But I'm going to talk about it today using the base languages that we have in the language. Because Lightning combines everything under one framework. So you don't have to piecemeal those things together by yourself. So in this first talk, we're going to cover XML and CSS, the declarative aspect of the language. So let's get right into it. First of all, we're going to do a quick review of this component-based architecture, what it means, and why it's so important in building single-page app. And we're going to contrast that with other popular frameworks. So in its days, for example, the last one, Flash, was extremely popular. It had a marketplace where people could buy and sell components. And it was really easy to build complex applications because you could reuse those components inside of your application. There's another framework that's coming that I've mentioned before, the W3C web components, where you're going to be able to have native support in the browser. And Lightning sits right at the junction of those 2 trends on this proven web component infrastructure. And so much that the definition of one framework really applies to the other one. We define component as reusable section of the UI. W3C says it's a widget. And the same thing with Flash. They talk about widget also. Like a button, a checkbox, or a menu bar. So whatever you learn in these other frameworks, you can transfer as skills to Lightning. Like this component-based framework is also object-oriented. So we support everything that you would expect in this object-oriented world. So we have polymorphism with inheritance and interfaces. We have composition, and that's a focus, and I'm going to talk about this a little bit later. Composition is really important. It's really a way to create your application in Lightning. We support obvious encapsulation, so you can have more easily a separation of concern. So if you do something that in your component and you don't want anybody to play with the internals, then you have a private context. And with inheritance, well, we allowed you to create base components that accumulate all of the common functionality that you want in a group of components, and you can then specialize that by subclasses. All of this allows us to do modularity, which is another focus of the platform. But there's a slight difference between between component-based architecture and object-oriented or classic object-oriented programming. In classic object-oriented programming, you want to write according to a mental model. So you create an abstract object that you subclass, and each subclass adds more precision to what the object is. With a component-based architecture, we do something different. We glue together components like a hardware store, nuts and bolts, and you build something with those small bits and pieces. And a great way to show the difference between the two or illustrate it is to think about building a Ferrari. If we do it with inheritance, we would start with a car, and then we would have maybe some abstract method that we would then override as a Formula One, and we go down and down until we have our Ferrari. In a component-based architecture, we divide the concerns differently. We want to build standalone small bits and pieces like a frame, a turbo engine, tires, a cockpit, and we assemble them. So it's a very different way to think about your application. Now let's take a look at the structure of a component, one of those things, and for this, we're gonna run this little demo. If we can cue the demo. So I have here an OR application. I have at the top an HTML select statement, and at the bottom I have an input select, a Lightning component, input select. So this is what's going to render. We can see that the two control are doing exactly the same thing. So when we think about our widgets, we can think that the framework allows us to build custom HTML components. It's very, very similar. So we build custom tags, and that's how we use them. Now this is another one where I'm going to take an HTML5 component, a meter, and I've created my own implementation of a meter. I've created a custom, a C meter. And this is what's inside that C meter. I have an attribute, a value of type decimal. And inside of the component, I have 4 nested divs. And I take that value and I use it in an expression. So what we're going to do, we're going to run these two side by side and see how they compare. So the difference between the two, I've made the CSS a little bit different. So they have we can easily tell them apart. The bottom one is my Lightning component. And if I look at how the DOM is created, we can see these 4 nested divs. And if I take a look at my meter tag, I can open it and I can see something special. I can see the shadow DOM because I've turned on in my browser a feature that allows me to see the underlying implementation of that HTML5 component. And if we look inside it, if we open that shadow DOM, we can see that it's also made of 4 nested divs. So this is actually how we created the simple custom component. We've copied this idea. So Lightning is trying to follow web standard, the W3C web component approach. Now we can go back to the slides. Let's talk about component bundles. A bundle is a folder that contains all of the resources owned by a component. there's always one XML file in the component, and the folder has the name of your component. That XML file has an extension that defines what type of component you have. You can have a component, an application, an interface, an event. It's given by the extension on that XML file. This is an example. You can see that this component has on the opening tag, we are setting some attributes. We're making this component extensible. We are declaring an attribute, a value of type decimal, and we're setting a value, the body. We're setting it to a div. So if we recap what we saw, in a component, I have a base tag that defines the type, component, application, interface, event. I declare attributes on that tag. I set values. So I could have implement if I want to extend, abstract if I want to prevent creating an instance of a component. I can make it extensible. It's off by default, but if you want to create subclasses, you have to mark it extensible. We also declare new attributes, and this is how it's done. We're going to see more details about it later. And we also can set attributes. Now, this set is not a declaration, it's actually a setting. And we use it primarily, the syntax, to set facets. And we're going to cover this a little bit later. This RS set for attribute body, it's not required, by the way, because body is defined by default on all components. So this is how you would normally write a component. You declare your attributes on top, and everything between the opening and the closing tag is the body. On this component here, I'm declaring two attributes. I have a label, and I have an amount, and I'm reusing label inside it and passing it to a label HTML component. And then I have an amount that I'm passing, instead of passing it as a body, I pass it as an attribute value on my meter tag. Let's take a look at an example of how this works. So we're going to look at a new video with two applications. We're going to take an application, we're going to declare an attribute, and inside it, we're going to put a component. So this is a great way to test a component. If you want to play with a component, you can just do that. And right on the URL is a bit small, but you can see that I have set an attribute label equal to cancel. And if I run this, I get my cancel button. If I change it to something else, OK, then I get my OK button. So this is a great way to test your components. We can do that also with the meter tag, where we declare an attribute, and we pass it to the meter. And then if we run the example, we saw that meter element before. It's the same attribute that's going to be reused inside. And then we're going to get to the demo. Here we go. So we can see that this application is receiving a 0.75 as a value. I can change it, make it 0.5, I redraw. So this is a great way to test your components, to create a little wrapper application to test it. So let's review what we saw with component attributes. Attributes are used to pass value to components. The declaration must have a name and a type. It can have optionally a default value, and you can specify required. So if it's not required, if it's required and you don't supply a value, the framework will give an error. The attributes are reusable declaratively inside of the component. You don't have to wire anything with JavaScript. Declaratively, you can reuse them in those expressions. And the reference always follow v.attribute name. Now, you can look inside of an attribute. Say you have an object or an array. You can look inside by following the dot notation. So if you have an object in an attribute name, you can look at each member of it, and you can hook this inside of your component. The framework will understand it. Same thing with arrays. You can do dot index, or you can use a square bracket notation. And you can go deeper. You can go multiple level deep if it's what your application requires. Be careful, though, there's a cost involved with this, because it's not supported natively by JavaScript, so we have to emulate it. Now, when we have a body, the children always populates the body attribute of its parents. So this is something that I want to cover quickly. We have here 3 components. At the bottom, we have an application that's using a child component, and it's setting the text in italics in it. That is then, if we look at what's in this child component, it's actually going to wrap it with a paragraph tag. And this is extending the parent, and the parent is adding a title to it. So this is how it works if you do the math. We can see that this is going backward compared to normal inheritance. So the parent decides what's going to happen with the child. And let's take a quick look at an example of this. So this is exactly the same example I've showed you. We have this child component that has a text in italics in it. And by default, defined in it, we have this wrapper. And we extend a simple parent, and the simple parent then outputs this title element. And if we run this in the browser, then we can see what we expect. We're going to have a title, and we're going to have an italic text underneath. Here we go. So nothing special here. But if I do a different type of a component, I will just want to show that the top parent always decides what's going to happen. I'm going to copy those 3 components. They are going to be exactly the same, but I'm going to create an ignored child. And that child would extend an ignoring parent. And the parent will not have inside it its v-body. So what's going to happen? So this is the child. We're passing the same text in italics. This is the child, which is using its v-body that it's receiving. But when we look at this ignoring parent, we don't have a tag. We don't have a v-body. So all of the work done by the child, all of the attribute passed to the child will not be rendered. So in this case, we're only going to have a title that's going to be rendered. Here we go. So think about this. Some components might be giving you a different behavior if you forget to use the body that you receive from the child. So this body attribute, it's declared by default on all components, so it's normal because we can pass to any component anything between the opening and the closing tag, so we absolutely need to have the body attribute declared by default. It's a special type. It's an aura component array. We call that a facet. It's equivalent to a node property like inner HTML or children. There's always one body instance per level of inheritance. As we saw, we had this child, the parent, and the current instance. So we had these 3 bodies. The body has this peculiar mode of inheritance, as I said, where the top parent decides ultimately what's happening, what will be rendered. And the child cannot override what the parent is doing. Now let's go with in expressions. Expressions, there are 2 types, mainly. One is property reference, so we just take an attribute and we use it inside of the component. And we have also expression functions. They look like JavaScript, but they're a little bit different. Because what we want to do is simplify the work at the UI level. We never want to output null, undefined, not a number. So this expression language cleans up the data for you. For example, if you have null plus ABC or string, in JavaScript, it will give you null ABC. But in our expression language, it will do the right thing. It will just give you that string. Same thing if you have undefined and null, that's not a number. And you never want to output that in the UI. So the framework does the right thing. This addition will give you an empty string. So this is very, very powerful. And it's used directly inside of our components. In this case, I'm declaring a style. And I'm creating an array. I'm creating a string based on the value that I receive. Now, this expression language has 4 main usage. The first one is with the notation curly pound. This curly pound notation is very similar to JavaScript, the way we pass attributes to a function or values to a function. So if you pass a string and the component modifies a string, nobody else will see it. If you pass an object, because it's a pointer, if you modify a property on that object, then it will leak your component. It will go outside, and everybody will be able to see it, but will not be notified. So you will not get a re-rendering. If you want that, if you want to change listeners, you use the curly pound, or the curly bang, the second one, notation. And that, even if it's a string, even if it's a number, a simple JavaScript type, if this component, this UI button, was to change this value, then it will propagate and re-render all of the other components that are making use of this attribute. So this is very powerful. We provide the two-way because obviously there's a performance cost, and maybe you don't want to have this behavior. Now, the other type of expressions, as I said, are functions. Overall, there are two types. You can do an equation, a mathematical equation, but a very simple one, and you can combine them, is to use ternary operators. And this is one way of doing it. You can use that to provide different strings. You can use that to pass different parameters to other components. Now let's look at key components. As we saw, we had this HTML component. It's a div, it's a P, it's a paragraph, it's an anchor. They all extend this base Aura HTML component. They can be created directly if you want to use this complete syntax, where you can specify the tag. If your component requires to have different tags created depending on a value, you can just pass which tag you want in the tag attribute. We support the majority of HTML5 tags. We don't support the one that we think are unsafe, unused, or unnecessary. And these HTML components are not extensible. Neither is the base or HTML. Now let's take a look at more of those components. Let's take a look at our if and our render if, which are our conditionals. So in this component, I'm going to create an X meter. This X meter as a conditional that decides if I'm going to use the HTML5 meter or my custom meter based on a Boolean native that I pass to the isTrue attribute on my or if. And I can create this else. I could use this alternate syntax to use the body, to set the body, so we see that this is more symmetric. But this is not required. We don't have to see it because by default, everything between the opening tag and the closing tag is the body. So that's the consequent. Now in this test application, I'm going to output a few of them where I set the values statically. I'm going to pass a native Boolean to them that I'm going to control. I'm going to put a little text using a ternary operator here to have an idea of what's going on with the application. And I created a button that's going to call a controller method. We'll see that in more details, but very simply what we do, we get this native attribute, we negate it, and we write it back. So if we run this component, this is what's going to happen. As we click on toggle, we're going to switch between our HTML5 and our custom component, as we expected. Now there's another component that can be used for conditional. It's Aura render if. And if we use it in a different application, we can see that it has exactly the same behavior. There's a difference, though, under the hood. Even if it looks and is used exactly the same way, there's a difference that we're going to cover in more details. Let's go back to the slides. So the conditional, what we saw, let's recap on this. There are two, or if or render if. There's an attribute which is our condition, is true. And we can have a body and optionally an else statement. We don't need the else statement. Why we have two? Well, Aura render if is the naive implementation. Under the hood, it's created like this. It's a ternary operator. Now, the problem with this is that we need to create the body and we need to create the else, the alternative statement. So we need to create both sets of components, even if we're only going to render one and use one. So it's obviously inefficient. So this is why we have if, which uses a template and is more performant. So you'll see render if. You might need it in some very special case, but normally you only use or if. I wanted to mention the two because you're going to see them. Now let's take a look at iterations, how to do loops in the framework. Now for this, I've created a first iteration where I take a list of items. Lightning will convert this to an array. And I declare which variable I want to use inside, item. And it's going to put each one of them inside of the item. And I pass this to my meter component. The other thing I'm doing with my custom meter, and this time I use an attribute that's declared on my application, which is initialized the same way. And we're looping exactly the same way over this application. Now, the difference here is going to play with another controller method, which I've hooked by using a button. And inside it, what I'm doing is I'm getting my items, I'm reversing the array, and I'm writing them back. So if I run the example, this is what I'm going to get. Here we go. So if I press toggle, I'm going to invert the rendering of my component. All right, nothing special here. Let's go back to the slide. Let's recap. Loops, there's one component to do it. It's called or iteration. The body is the template to create multiple instances. We iterate over an array attribute that you can configure called item. And you can declare, you can choose how it's named internally. We can give you access also to index var. So if you want to output 1, 2, 3, and whatever is been currently looped over. And it also supports start and end if you don't want to start at the beginning of the array and render the whole array. Now let's look at some implementation detail, what's happening under the hood. Now, two things to cover. One is the difference between Lightning and templating engine, and the second one is about counting component instances. It's just a little bit of optimization and performance in your component. Now, it's really easy to think about Lightning as a template engine that's going to parse the XML on the client, but actually the XML never goes to the client. If we were to use something like mustache or handlebar or underscore template, we would probably have a string with a bunch of placeholders. The tool will convert that to HTML by replacing those variables, and that will be passed to the DOM for rendering. This is not what we do with Lightning. We start on the server with the XML and we convert it to Java and send it to the client as JSON. You never have XML on the client. And this JSON, when it's required, create JavaScript instances of those components. And those are rendering on the DOM. Those are responsible of creating the rendered version. So it's very, very different. The other thing is how to count component instances. What is the cost of those instances? So in this case here, I have two components. Component at the top and an application at the bottom. My component at the top has those 4 nested div, as we saw before. So if we were to create this component, we would have four components created. And because I have a base component that is extending the base or a component, I would create 2 instances, my current and my parent, for a total of 6. In this application, I would do the same thing. The application would extend the base application, so that's 2 components. Here, I put a meter tag, and this meter tag has a text inside it, so that's 2 components. And that C meter, my custom meter, is exactly the same structure as what we saw above. So it has 6 components, and because we give it a text element, it's going to have a total of 7 components. So that's a total of 18. We can count these components in the browser. We expose a method. You can do this in the console, or as I like to do it for El Cheapo performance tool, create a bookmarklet. And we're going to see how this works. If we cue the next demo, this is the example I've showed you with those this HTML5 meter and my custom meters. And then if I run the demo, now I'm going to be wrapped inside here a complex application, so I'm going to break out. I'm just going to want to show that one application. And if I run my bookmarklet, I get the expected 18 components. Now we can repeat the process and take a look at this Aura if and Aura render if and count the components. In Aura if, in the base case, I get 56 components. If I switch to my custom, I get obviously a little bit more components. I get 80. But if I was to use the render if, because we create both sides, here I'm just showing that it's not changing. We always get the same values. And if you use the render if, we had 110. We have a lot more components because we have created the branch that doesn't render. We have created the two branches. And whatever we do, we always have a large amount of components. So that's one thing to use in your application. You want to focus on using Aura render, Aura if. So that's it for XML. Let's take a look at CSS. I want to cover three things here: how to use CSS in components, the limits of encapsulation, and OOCSS, a little bit of an introduction to OOCSS. So CSS in components, we're going to start with a small demo. A simple application that's using a contact form. So I've created a custom contact form, and I've taken this from somewhere from the web. I wanted a simple example. I wanted to show that we can just do cut and paste, copy and paste, and put it in our components, and it will work. And I copied the CSS the same way that was attached to that form. The only thing I've done is I've changed the top element. I've added this keyword, .this. And if I look at how this is going to be rendered in a custom application, I break out, I can see that I can see the result as expected on the original. Now this form is receiving a custom CSS class, c.contact, which is the name of my component there. Namespace plus the name of the component. It's receiving this at the top. And all of the HTML rules, wherever I had the keyword this, it's been converted to this pseudo class. So this is how we achieve specificity in our components, and we prevent styles from one component to extend and to bleed outside to other components. If we go back to the slides, let's recap what we saw. CSS, it's a file named component.css placed in your component bundle, and all rules start with this. What Lightning does, it wires the file to the CMP automatically. You have nothing to do. It transfers everything to the client. It converts this to a pseudo class, and it also puts this pseudo class to the top elements inside of your component. So it wires everything for you. You have nothing to do. And this is how we achieve scoping, because namespace : component, which is a source of your custom pseudo class, is unique in your application. But there are limits to this. And we're going to see more examples. So I have a div that contains 3 widgets. There's a C widget, another C widget, and a C widget list inside it. Those widgets are really simple. They output an article tag. That's all they do. And the widget list outputs 2 of those article tags. So we should get, if we take a look at what's going to be rendered, we should get 4 of those articles in the DOM. And if we take a look, this is exactly what we have, a div with 4 articles in it. Now, where we have to be careful when we style is, first of all, styling crosses component boundaries. So in this case, this rule, this article will affect everything below. So if it's put at the application level and my application does not have the article tag inside it, it's going to affect what's inside of the component. So to get around the problem, we might want to be a bit more specific with our CSS, because as we see, this border has been applied to all of my article tags. And to be more specific, we could do something like this, right? Which would prevent the bleeding. The second problem we have to be aware of is no CSS file means no this or no pseudo class created. So with this rule, I'm trying to style those widgets using their pseudo class. I'm trying to style CWidget and CWidget list with bold. But as we saw in the rendering, we don't have bold to all of those articles applied. We only have it for widget list. And the reason is that my widget doesn't have its own CSS file. So there was no pseudo class added to it. So we have to be careful. As we see in the DOM on the right side, we have no pseudo class added to these because they have no CSS. We only have it for the article list or the widget list. So that's another thing to be aware of. Now the attribute class, so this is only what we had. We had just one element inside of the CSS for that widget list. If we go back to this, yes. The attribute class by default is not defined on custom component. It's only defined on HTML components. If you want it, you have to implement it yourself. So this dot first, if I was to change the component and I would try to apply a style on a component that doesn't support it, I will see an error. So let's take this class first and apply it to widget list. And as you can see, if I try to save this, the system is giving me an error. Class was not found on widget list. And if we look at the component inside, we can see there's nothing. There's no attribute class defined, as we have in our custom widget. Next. Multiple top elements means multiple this added. So in my article, I have multiple, and in my widget list, I have multiple articles, so each one will receive this pseudo class. So I need to, if I want to style this, I'm going to affect all, and I use this pseudo class, I will affect all of them. So if I had something else in that component that was not an article, it would be affected because it would receive also this pseudo class. And this is why I might want to use something, styling rule that is a bit more specific if I want to do this. Now, the next thing is if you change the component structure, we're going to greatly affect the way everything is rendered, the way these rules are applied. So if I go back to my basic app, take a little bit for the demo to catch up. There we go. And if I remove the outside div and I try to re-render what I had, I will see that reload, all of my styles are gone. And the reason is because my rules are applied to the top. So this is now applied to every one of those. So I need to change my rule, and I'm going to recover. This is a reddish color. And if I update this and I reload, I will see that at least I'm getting back my red color. So in general, we don't want to use styling based on pseudo class because it's kind of breaking the encapsulation. We have to know what's happening inside of the component. So we want to avoid it. So just to go back to recap, limit of encapsulation. Styling crosses component boundaries. No CSS files mean no this added, no pseudo class created. Multiple top element also mean multiple pseudo class added. Removing the top element changes the rules, and there's no attribute class by default on your custom component. You have to define it yourself and decide where it's going to be applied. Last item before we take a break, using OOCSS. So what's the landscape before OOCSS? Well, if we have components that each one define its own style, we end up with a lot of repetition because we have a lot of styles that need to travel together. And also, changing look and feel for an application means opening a lot of components. One way to get around this, we might decide to do some skinning, and we've tried it. So we try to override styles with a global style sheet. But again, the problem here is that we break encapsulation, and it's inherently unstable, because as soon as somebody changes a component, we break their styling. There's something coming in CSS, and we support a version of that, which is CSS variables. But this also has limits, because the styles are usually related. So you might be tempted to change a color of a text, but then you have to change the background that goes with it, because those clash now. But then this background is used somewhere else. So then you go in this very complex, trying to find, looking inside of the components, what are the relationship between those styles? Typically, this approach would be using a redline, where you would define everything that is in your UI, and you would try to apply that to all of your components. And that's a lot of work. And we've tried it. This is why we're going to OOCSS. OOCSS is not something that's supported by the browser. It's actually a technique to write CSS. And what you do is you create CSS classes that work together, and each one contains a lot of CSS that is related. There's a lot of framework out there already that do that. These are a few ones. And the benefit is that you create reusable CSS, you reduce your CSS bloat, and you improve consistency. It's also making the app more predictable over time. It's also great because you have now an abstraction layer. You talk to an API. You talk to OOCSS classes when you want to style your component, which helps maintain the separation of concern between presentation and structure. We have at Salesforce last year launched our own OOCSS framework called SLDS. I will not go into details because this is a large subject and we have other sessions for this. This is where you can find the documentation. And to use it, it's super simple. You can install a package, you add a declaration, and you start writing your component. There's nothing to do. All the wiring is done for you. And it's an open source project also. So you can download it and install it on other frameworks. Let's take a look at one last demo before we take a break. This is the same form that I have styled using SLDS. It looks very much like our interface, a Salesforce SFX S1 interface. So if you want to write something using this SLDS styling, your component will feel at home on the platform. This is what I had to do. I had to import this static resource and create my new SLDS contact. I decided to call it SLDS by reference. And inside, I've added all of the OOCSS rules. This looks complex, but it's very, very logic. And once you understand it, it's really easy to use and read. Now, what's very interesting with this is now my component has only accidental CSS, only things that I need to fix for that component. In this case, I wanted my text area to be bigger. And my component doesn't have anything else. Everything else is supported by the OOCSS framework. Let's go back to the slides. So this is all I had for you for this first session. I'm going to give you back 5 minutes of your time. We're going to have a 25-minute break. And then we're going to come back to the second part where we're going to talk about the programmatic aspects of the language, JavaScript and Apex. Thank you.